All right, let's look at the rotations in 3D. All right, so it's going to be a little bit challenging since we have to think three-dimensionally. All right, can we come up with a matrix which corresponds to the rotation in 3D? All right, especially the rotation about the axes. All right, so let's do that. So first one, let's try to come up with a 3 by 3 matrix which corresponds to a rotation about the x-axis. All right, so we want to rotate which way? Let's see. So you have an x-axis here. So this is the counterclockwise direction. So we're going to rotate that way by theta. All right. So, but there's no change in x coordinates. So we know that if you want to come up with a matrix, so it's going to be a 3 by 3 matrix. All right. All right. And the usual first, column, first row corresponds to variable x, and second column variable y, and third row is corresponding to variables z. So I'm going to just put that in x, y, z. All right. So since we don't want any change to the x coordinate, so we can see that this is going to be just a 1 right here. So there's no change on x. All right, so I'm going to put 0 here, and I'm going to put 0 there. All right, I'm going to put 0 there. I'm going to put the 0 there. All right, then you can kind of lose the coordinates. So you basically throw away the x-axis. Then you basically have a YZ plane, and then we want to think about the rotation. But we know that the rotation is cosine, negative sine, sine, cosine, right? So would this work? So you have a cosine of theta here, negative sine of theta, and here's a sine of theta, and cosine of theta, right? And as it turns out, this is the rotation about the x-axis. All right, so it's fairly easy, right? And I'm going to actually erase these so that it looks prettier here. All right, can we come up with a matrix corresponding to rotation about the y-axis? All right, so here's the picture. So y-axis here, right? And then you want the counterclockwise rotation with y pointing upward, right? So we want to rotate this way, right? By theta. All right, so let's do the same approach. And so we know that we don't want anything happening to y because there's no change in y coordinates. So you're going to have a 1 here, second row, second column, right? And then it's going to be 0 in the same column and zeros in the same row, right? All right. Then the natural approach would be, all right, now we kind of throw away the y-axis, right? Then we want to do cosine, negative sine, sine, cosine. All right, so let's do that. Here you have a cosine theta, negative sine theta, and then here's a sine theta and cosine theta. All right. All right. So we think this is going to be the one. All right. And it's almost. All right. So if you do this matrix, what happens is we take x. So here's the first column corresponds to x. Third column corresponds to z. So it's rotating, right, on the xz plane, and it actually rotates the other way around because since the x-axis comes first and then z-axis, you are actually, unfortunately, rotating this way, right? So which is not what we want. We want counterclockwise. So we have to fix it. But since you're just going backward, you can just stick in negative theta instead of positive theta, right? So we can do that, and the easy fix would be cosine is even function. Putting a negative theta in there will not make any difference. So cosine of theta stays the same, but the sine is an odd function. So if you plug in negative theta, it's going to change its sign. So all you really have to do is change the sign of the sine function, right? Then you put the negative sign there. All right, that way it's going to rotate in the direction that we want. All right. So let's do the rotation about the z-axis. All right, so z-axis, this one's probably nice. All right, so z-axis on top, and we just want to rotate this way, right? Counterclockwise theta. All right, so this one, it's actually one of the easier one. All right, since we don't want anything happen to z-axis, you're going to have a 1, a z-coordinate, in the third row, third column. So in the same column, you got zeros. In the same row, you get zeros. All right. So now you can kind of ignore the z-coordinate and then do the rotation on xy plane, which we already know how to do. It's cosine of theta, negative sine of theta, and a sine of theta, and cosine of theta. All right. And this is the matrix corresponding to the rotation about the z-axis. All right, so the middle one is a little bit tricky because it kind of rotates the other way around, but we can easily fix it by kind of switching a sign on sign. And other ones are pretty straightforward. All right, that's it. I hope that this was clear.